Let's look at final exam question number 58, found on page 673 of Teach Yourself Electricity and Electronics, 5th edition. The question asks us about a radio transmitter and an antenna that are not matched in terms of impedance. What we do know is that the transmitter, that's what this abbreviation stands for, is designed to work into a purely resistive 50 ohm load, and the antenna and its attendant length of feed line, if any, is 600 ohms purely resistive. So we know that these two impedances are both purely resistive, which makes things a great deal simpler than they would be if there were reactance involved. Suppose that we decide that we want to make a quarter wavelength matching section of transmission line to match this impedance to that, so that the transmitter will see a purely resistive impedance of 50 ohms, even though the antenna system is a purely resistive impedance of 600 ohms. Well, now the quarter wavelength matching section will represent an electrical quarter wavelength, which will be somewhat shorter than a free space quarter wavelength, depending on the type of transmission line, and that involves figuring out the exact length of that. We'd need to know the frequency, and we'd need to know the so-called velocity factor of the line, where the velocity factor is the proportion of the speed of light that the electromagnetic signal actually follows. But that isn't really relevant here. The only thing the question is asking us for is the characteristic impedance, which we would call Z sub 0, of this piece of transmission line. In order to make that system work, what characteristic impedance do we need to choose for that transmission line? If we can buy it in a standard characteristic impedance of the right value, fine, but chances are we're going to have to make it ourselves. We're going to have to home brew it. We can calculate that fairly easily. The characteristic impedance of a quarter wavelength matching section is the so-called geometric mean of the transmitter impedance, if it's purely resistive. Let's call them R for resistances. The resistive impedance of the transmitter times the resistive impedance of the antenna system, the square root of that. That's what a geometric mean is. A geometric mean is the square root of the product of two numbers. That's differentiated from the arithmetic mean, or average, which is half the sum of the numbers. The geometric mean is this. Well, we already know those values. 50 for the transmitter, 600 for the antenna. So when we multiply this out, we're going to get the square root of 30,000. And you take your handy-dandy calculator and work that out and round it off to 3 significant figures, because actually we were given the transmitter value here, 50.0. We were given that to 3 significant figures, and this to 3 significant figures as well. So we get the square root of 30,000 rounded off to 3 significant figures. That works out to be 173 ohms, which is choice D, as in delta.